So I'm here today with Andy Hunt. Thanks for joining me, Andy.
Hey, thanks for having me, Dave.
So Andy Hunt is a programmer turned consultant, author, and publisher. He's authored a dozen books, including the best-selling The Pragmatic Programmer, was one of the 17 authors of the Agile Manifesto and founders of the Agile Alliance, and co-founded the Pragmatic Bookshelf, publishing award-winning and critically acclaimed books for software developers. He's currently writing science fiction and experimenting with the Grows method. Actually, I'll get into asking about the Grows method, but before we start with any questions, I want to tell a story about that Pragmatic Programmer and the influence that's had on my career. I was 7 or 8 years into my career when I read that in, I think it was late 99 as part of a study group at work. And that book landed on me in the perfect mix of like 1/3 stuff I knew and knew cold. 1/3 stuff I knew but hadn't really put into any kind of framework of knowledge yet. And 1/3 stuff that was new and awesome and I wanted to adopt at work immediately. And that book has influenced my career. And another amazing thing is that when I read that book, Andy and Dave, the authors, were like heroes to me. And then in 2003, Andy, I met you at the JAU conference in Aarhus, Denmark. All right, did I have that right? Yeah.
Aarhus.
And so you became, and we started a conversation, and you became not just this hero, but like a mentor to me. And then as we've crossed paths over the years with various books and various conferences and stuff, it's really grown into a friendship. And that's one of the cool things about, not just you, but this career path is that I know many people that were like these untouchable people I thought were on pedestals, and they end up just in the circle of people over the years. But I appreciate that, and I wanted to thank you for that while I had the chance.
Oh, it's always good to hear. Glad I could be there. Glad I could be of service over the years.
So I know you have a lot of different pans in the fire, a lot of different steps on your career path. But what do you do? What's up now?
So I laughingly tell people, at a party or some social event, oh, what do you do for a living? I say, I answer emails. Because, honestly, that feels like it's about 90% of it is, answering,
Right.
flinging emails and getting back to people. But more broadly, I'd have to say I solve problems. And sometimes that's a bug in some code somewhere. Maybe it's in some production code in Ruby or something like that. Maybe it's a bit of shell script. Maybe it's a cron tab. Maybe it's an installation issue, a Docker image, whatever, some kind of technical bug. A lot of the times, because I own the publishing business, it's a bug in policy or workflow or something more businessy related. And then that gets into a frightful amount of time with something that's a legal issue or an accounting issue. And I'm not a lawyer, I'm not an accountant, but these are things that come up. So it kind of cracks me up. People talk about full stack development being, and they take this sort of view of like, oh, it's front end and back end. It's like, no, full stack development actually goes from like understanding, TTL logic and CMOS gates and, K-maps and stuff up through your front end and back end, up to international treaty and legal issues and, right?
Yeah.
That's full stack. And I can honestly say, I can hit problems anywhere on that list in a given week.
Yeah, I spent a decade working with the State Department. So yeah, I knew a bunch of international treaty stuff, the Wassenaar Agreement and all kinds of stuff. The SALT Treaty were all stuff that were relevant to my day job.
Yeah, and that's something I think that gets overlooked a little in most technical education. We focus on writing hello world and making it compile and making it run. And in the old days, maybe that was enough. But certainly these days, that's really just the beginning of it. We talk about gathering requirements or analyzing requirements, and that's really the wrong word. It's a discussion, right? It's ongoing, right? Like your work with the State Department. It's not just, here, do this thing. That opens up 100 questions. Well, what happens when this happens? What about that? What about this other thing? So you have to learn the domain, whatever you're programming in, whether you're working for Facebook or the State Department or some small startup or a biotech or pharma. You have to learn about the environment and the domain as well. So the real core skill, and what I still have to do all the time, is I'm always learning. You're always learning. What you learn in school whatever the tech is, whatever the philosophy behind it, the job that you're going to have after school probably hasn't been invented yet, right?
Yeah.
It's not there. It's going to be something different. It may not be wildly different. It may only be a little bit different. It could be completely different. Who knows? At the rate things are changing in 2020, I'm not going to make any bets for the next 5 to 10 years. But you will be working in something for the most of your career that doesn't exist yet. And to be able to navigate those waters, you have to always be learning, always picking up some new bit of tech, some new skill, and not just in the technical area, right? As we were saying, you need to know a little bit about psychology, a little bit about economics, kind of these things that we'd probably rather not, but we run into all the time. That's just
it's kind of lost when we're in class. We're learning to talk to the machine, but we write software about something. So, if you're going to write software for music composition, you're going to end up knowing a lot of music theory. If you're writing software for international trade, you're going to end up knowing a lot of international stuff. Tax software, tax code. You end up needing to know that area in order to codify it.
Yeah, absolutely. And again, I think that's something we give short focus to, but also more importantly, how do you prepare to learn these things, right? So you get a new job at some new company that's doing, pharma trials or something you have no experience at. Boom, here's this whole world. Okay, now learn it quick. How do you do that? How do you go about that? And that I think is one of the most important skills that you need to pick up anywhere along the line from high school to college. I think many people hit college or that equivalent, and they don't really have that kind of skill of how to learn something quickly or their first job. But that's something with luck that you pick up and learn how to do. And if you're not lucky and no one has shown you, that's going to make the career a whole lot harder.
Mm-hmm. Yeah. Well, so how did you get into the field?
So I read a book, which is something I highly recommend. Everyone does all the time. Always have one to three titles that you're reading all the time. Elon Musk has he reads like 4 books a day, some ridiculous amount of stuff, and that's what it takes. But I was reading a book on the new microprocessors. This was in the mid 70s, when dinosaurs grazed the land. And it was painting this picture of how these room-sized computers might be as small as a refrigerator someday, and how awesome that would be, and all the hope, all the things that could come of this. I was like, that just sounds cool. I want to tinker with this. I want to play with this. So that got me interested in it, and so I was interested in hardware early on. I think I was in middle school when I soldered up a simple resistor-based switch organ that would play, my first synthesizer, right? Bunch of calculated resistors on a ladder generating a tone in like middle school, So I was into tech and into programming pretty early, and then I went to college, got a degree in computer science, and again, I don't think any particular tech that I learned in college I never used in the workplace. Right. The language we used at the time was Modula 2 by Nicholas Wirth, and nobody used that commercially. So that was there was nothing you could take with you from that. Now, a lot of the lessons behind different languages and different approaches, finite state automata, bits of theory, that's probably been helpful over the years, but definitely not any of the tech itself.
Yeah, that's an interesting discussion I get into often about the difference between computer science and software engineering. But I think that's a different video than what we want to record today.
That's a much longer discussion.
Right.
Is computer science is a good way to start, but yeah, that's a...
Right. Well, so how did you get from there to here?
So a circuitous path. I got a sort of a regulation first job out of college. And at the time, there was a recession was roaring along. Jobs were not plentiful, even in the programming sector. So I did what many folks did at the time. I went through a headhunter to get me a job. And I got a decent job at a giant, Fortune 5 faceless corporation that had 27 salary bands, right? So you're hired in as a, level 2 junior, blah, blah, whatever, kind of slot. And if that sounds like a completely typical dysfunctional large organization, it absolutely was. It was, years before Dilbert, but it was picture perfect of all the sorts of issues you might expect in that environment. So I did that for a couple of years and learned some things. But what was interesting to this conversation, what actually landed me that job above other candidates, was I had a skill they needed. I, at that point, had taught myself C and Unix. And skilled Unix programmers were very rare at the time. So that was something that, got me to the top of any pile of resumes. And they physically had piles of paper resumes, back in the day. But that was my angle. That was unique enough that got me through whatever gatekeeping to get in for the interviews. The other thing, which I'll mention, I always made certain to put on my resumes anything interesting or unusual hobby related. So in my case, I played trumpet and flugelhorn and keyboards, but I play brass instruments. And the flugelhorn is kind of an unusual instrument, right? It's you don't see a lot of that. And it's popular in jazz and some other genres, but it's not common. So someone's skating through the resumes and they see plays flugelhorn. Their first inclination is, the hell is that? But it's made an impression. It's like, oh, this is that guy with that weird thing on his whatever, right? Anything that helps you be memorable, that helps you stand out and preferably and provide value. So, hey, and he knows C and Unix. We need someone like that, right? You need that kind of angle. If you go in with, well, they know JavaScript and HTML, well, great. So does my grandmother. That by itself, that's not enough to get anyone's attention. It's going to be a lot harder to make it through like that.
Yeah, it gets you in the room, but it doesn't make you stand out.
It doesn't make you stand out. And, that's, depending on the market fluctuations, that might be fine. If people are desperate, they'll suck up all the available talent anyway. But I've never seen companies get that desperate, right? They're looking for something extra. They're looking for something extraordinary.
Yeah, that gets into a later question I have on my list is, what hobbies do you have and what's your life out of work like, outside of work?
There is no outside of work. So I have worked from home. I have had my home office for over 25 years. So when the pandemic hit, as we were talking about earlier, some people were very uncomfortable, or at least not used to the idea of working remote and working from home. And of course, we've done this forever. So it's like, no big deal. But so on the one hand, the plus side of that is that, you save a lot on wearing suits and formal wear and pants even, really. So that's handy. But then, and especially owning the publishing business, you're never really off the clock. So, some email comes in the wee hours and there's a problem, you're kind of on the hook for it. But I do try to ignore all that and spend some time with my hobbies. I enjoy music, obviously. I've played in bands locally. When time allows, I try to compose and write and record material. I enjoy woodworking a lot because that's a very different set of problems to be solved, and that has a pleasant, for me, a kind of tactile, very real world, tangible aspect to it. Learning to hand cut dovetails and seeing the result. It's not just ephemeral bits in the computer, right? You've actually made a thing.
Have you ever played around with 3D printing?
I have been sorely tempted because I think it's really interesting, but looking at the investment required and the amount of maintenance and tinkering just to get it to work, it's a little early in the life cycle for my tastes at the moment. Yeah. I'm waiting for it to be a little bit more consumer friendly of here, I want this, boom, more like a Star Trek replicator than a Model Ford where you're hand cranking.
Right. It's definitely a time sink and it's care and finicky machines. But, I've never been good at woodworking. I've always admired people that can create physical things like that. But now to design something on the computer, and I use this tool called OpenSCAD, where I program in a language that looks kind of like JavaScript. And so I don't like, start with a CAD tool where I design a shape. I'm literally saying, give me a sphere of this size, and now punch a hole in it like this. And so I design parts and print little pieces, and I print them with a plastic that has bamboo in it. And they come out feeling like little pieces of wood that I can use for puzzles or things I'm assembling. And it's just amazing to have something that I designed in code on the screen become a physical, tangible object. Just feels like I'm living in the future.
Definitely. And that's the kind of, that's the kind of cool thing. That's the kind of hope in the future that I really hope we don't lose. In the current environment and all the things that are going on. I remember growing up, I remember skipping school to watch one of the moon landings. Because it was important. It was cool. Right. Everyone was focused on this. It was a very hopeful thing. I remember when they named the first space shuttle the Enterprise, and it piggybacked on the 747, and that was a big deal, right? We had a lot more of that kind of, looking forward at cool tech, that kind of hopeful attitude back then, and we haven't lost it completely. I mean, as you say, with the 3D printing, a lot of these other things, the stuff that I do, I've got a music studio built here in the basement, and I've got more recording power on my phone than the Beatles had, than Led Zeppelin had, than any of these early groups, the early studios. Right. Just the tech that's commonly available blows away anything in history. It's really amazing, and that's not going to stop. That's going to get, that's going to be, I don't know, AI fueled and whatever in the next 5-10 years. It's like, write me a backing track that sounds like, fill in somebody, Lady Gaga, Nirvana, whoever, Billie Eilish, pick a style, boom, and there you go. It sounds just like them. So yeah, I mean, you never know where that kind of stuff's going to go, but I do think it's important that we keep an eye on that and keep hoping that, yes, this is cool. It's going to get better, and I can make it cooler. I can help get us there.
Yeah. Well, so I want to ask a question about languages and technologies that you've used professionally, but I'm sure if we were to just list them, we'd spend here for the next half hour, and it would be meaningless to the audience I hope I have. So
it's a long list.
Yeah, let me target a kind of question. Imagine you're a high schooler who may have used Scratch, maybe dabbled in Python, taken a year or so of Java. Describe a real project that you've worked on that may have been a Rube Goldberg-ish type thing that used a bunch of different pieces of technology together.
All of them.
Well, you and I have all worked on the thing that have, had the JavaScript that triggered when a front door opened and sent an SMS message to a mainframe in the back room that,
Absolutely. Yeah. Rubber bands not included.
Right.
We've done a lot of that over the years. One of the larger projects back when I first started consulting involved, let's see if I can remember this right, it was at least C and Delphi and SQL procedures, and I think there's some small talk in there, and and C++, yeah, and Corba. And I mean, the list goes. Oh, and it generated documentation. So there was something like with TROF or LaTeX, involved in that. But I mean, yeah, the list goes on. Even modern projects that I've used might have a little Ruby, a little Rust, maybe some Go, JavaScript. Right? It's like a virus; you can't get away from it.
You know what? I just thought of something. I know something that would be ideal to talk about. Tell me about your book publishing pipeline. I worked on that back in the day.
I have. There's two. There's the professional tech publishing pipeline that we use at Pragmatic Bookshelf, and that starts off with either Markdown or our flavor of XML, which is PML for Pragmatic Markup Language, but it's basically XML based, and that goes through a the game Mousetrap where you hit the thing. And
yeah.
Right. It's like that with XSLT and some Ruby processing, and there's some Java on the top. But there's a bunch of things that go through and basically run a very glorified XSLT transform to produce a number of different back-end output formats. So from this single common input format, we can make ebooks, We can make EPUBs, PDFs, MOBIs, print PDFs with the specialized requirements for physical printing, all these sorts of things. And it was interesting when Dave Thomas and I started the publishing business, we started it with an eye of, well, we should run this like a software project, right? Things should be under version control. There should be a continuous build machine. It should be, you should keep to the dry principle, right? You write the code once and the book code once. And if you actually have source code that runs in the book, you don't want to copy and paste that. You actually want to run that out on disk and just include it, right? This is what a software developer would do.
Right.
Turns out
that's the part that interests me about it back in the day, is that if you had source code in the book, you had tests that proved that code worked. You never saw source code in your books that had a typo in it. It was all legitimately tested, run stuff.
Exactly. And that's not what the rest of the industry to this day, most of them don't do that. You submit a manuscript to one of the larger publishers and they will have it rekeyed, from your Word document into InDesign or, one of these kind of publishing bits of software. And of course, all that rekeying that they're getting done in some, offshore cheap labor source somewhere, it introduces typos, introduces problems. And we took the software approach of, well, no, that's silly. We can do better. We can write some Ruby scripts, some Bash scripts, some transforms, and we can get around all those problems. And it just works. And we've been doing that now for 15 years, very successfully. For my science fiction books, and this is over the course of time, right? Back in the day, there was nothing like that, right? That was, our tool chain was really unique. For my science fiction, which doesn't have code listings or quite as many requirements, you can use open source Pandoc, kind of right out of the gate. You spray in some Markdown, you get your EPUB, you get your PDF, you get any number of output formats, and it's open source and available. And that's the other thing that I find really amazingly cool is almost anything that you want to try to put together and assemble, there's bits and pieces of it you can grab that are out there, especially in the more robust ecosystems like Python or up and coming Rust or Ruby. It's like, well, I need something to do this. Hey, there's a package for that. Boom, you're done. You glue it together, move on to the next problem. So and that really helps. Having that base to draw on really helps propel the industry forward, because now you're not wasting time reinventing some low-level bit of the wheel. You can go on and build the wagon.
Let's time travel. Imagine you go back to yourself in high school. What would you tell yourself to prepare yourself for the career you've had?
I think I would caution myself not to get too attached to the stock standard narrative. Right. So the idea, especially then, was, you go to college, you get a degree, you get a job, you stay there. That was the model. It was, it was just starting to come off the idea that, people would take a job and stay there for 20 years, 30 years, get the gold watch and retire. And that was just starting to fall apart. Probably, I'm guessing mid 80s, maybe. And that's not the world of today at all. Right? Most tech people I know stay at a job 4 or 5 years tops. Yep. And they go on to the next one for whatever reason. Projects get funded, defunded, technology moves. It's a very volatile environment. So the idea of kind of assuming what your career path is going to be up front, I almost guarantee you it's not going to be that. It's going to be different. I would never have guessed that I would end up as an author and publisher. I wasn't headed in that direction. I was headed to be a programmer. But I noticed other people having problems programming. So I started, try and do it this way. Try and do this other thing. That led into writing the books. Writing the books led into the publishing company, right? So, the path went like this, none of which I would have expected, as a high school student or even in college. That wasn't what I was looking to do, but that's how it turned out. So, you really never know which way it's going to go, especially over 10 years, 20 years of the kind of progress, the kind of changes we've seen. My crystal ball is pretty murky. I have no idea what's going to happen 2 years from now, let alone 10. And I suspect no one else does either.
Yeah. Good advice. Yeah. Well, I have one last thing I want to show you. First of all, let me thank you for participating in this. This has been a great series of questions. But I want to tell you a story based on your long bio where you mentioned CPM, and even in this conversation, you talked a little bit about TTL logic and stuff like that. Well, about 5 or 6 years ago, I had a high school student come to me and say, Mr. Bock, I want to build a computer this summer. And I thought he was talking about ordering parts off of Newegg and assembling a gaming rig, right? And he was like, no, I actually want to design a motherboard and learn how chips work. And I was like, wow, you can't really do that with modern PCs because of the timing of the chips and the complexity of the boards. But I did something like that back in the 80s when I was in high school with a Z80 processor. And I actually brought the book to school. And we started searching online for whether this was even possible today, were the chips still manufactured? And we found a guy who lives just about 20 miles from us who makes and sells a kit about this. So let me switch over to my camera.
Can you even buy like 7400s and 7404s and all the
you
old
can still buy all that stuff, yeah. So let me show you this kit. I have it over here counting. So this is the computer. So right now it's running at 2 megahertz, but I can drop it down to 4 hertz with a clock right here. So what you're seeing here is just 16 LEDs, and it's just counting in binary. And it's counting so fast you can't even see here. And then there's this display screen that is showing all the status registers, but they're moving so fast you can't see them. Flipping switches, I can reprogram it and slow it down and write other stuff, and I have 16 input switches here to be able to do stuff. But it's a Z80 with 2K of ROM and 2K of RAM. And you can pull off this and put on this card, and this upgrades it to 64K of RAM and a CF card that has CPM on it. So this to me reminds me of that in Back to the Future when the DeLorean had the Mr. Fusion on the back. This semi-modern piece of technology grafted onto this stuff from 1978 that is more memory than probably existed on the face of the planet when CPM first came out. But this little rig can run CPM, and so to be able to go in and talk about what each of these chips are doing, and have a logic probe, and be able to show you why that processor, where the clock is, what that how that relates to the data that's flowing in and out to the RAM. It's just amazing to get down to this level, and you can't do it with a modern computer. Modern computer.
Right.
Yeah, they're just everything's integrated into one chip. You can't get inside and poke it. And I've since found this whole ecosystem. This is another computer like that. And this one it's just a backplane. It's not an S100, it's just a custom backplane. And there's the disk storage, the computer, and input-output on different cards. And I have dozens of different cards to give this thing different capabilities. So, it's just awesome to be able to show students that. And so with my group of students at a high school, every year I get 2 or 3 students to build that as kind of an extracurricular project.
That's awesome. And I highly recommend that. Like I said before, talking about the full stack, you really are benefited by having that kind of low-level understanding about what's going on with the chips, right, what's going on in assembly language, how your code relates to that. And it's not just an esoteric thing, because what happens is when you run into a bug and you run into a problem in the day-to-day stuff, having that low-level understanding helps you analyze and fix the problem so much quicker, because it's not magic. You know what's going on. You've got a better idea of, okay, well, if this is failing, these are the likely things that are causing that, instead of just, I don't know, it's magic. I don't know how it works. So yeah, I highly, highly recommend that. Absolutely.
When I saw CPM in your bio, I was like, oh, I got to tell him I'm using CPM in the classroom now.
The good old days.
Yeah. Well, thanks for your time today, Andy. This has been a blast.
All right. Thanks so much for having me.